Assalamualaikum and salam sejahtera to Sir Firdaus. So this is our combination teamwork. So all of us in this group will explain about title Traverse, and here is the video. Introduction to traverse surveying. Traversing is a method of control survey to establish control points. A traverse must start with control station, which is non-station non-coordinate. It is a method of transferring coordinates.
Definition of traverse is where a series of points or station where each one indivisible with its adjacent points. The lines joining these stations are the traverse lines. Consists of the measurement of angles, which is bearing, and the length, which is distance of each line.
Trial traversing is that type of survey in which a number of connecting surveying lines are measured with the help of a trialite for measuring angle and tape for measuring distance.
Purpose of the traverser is to provide a control point system that can be plotted accurately on the plan. Then details such as surface position and natural correction can be described based on horizontal line and measuring station.
The purpose of traverse is setting out two positions of wood, holding or the other new construction when can be then be set out on the ground from the traverse to define the position of design requirement, road building and others.
Other purpose of traverse is property survey to establish boundaries, and last but not least is the ground control surveys for mapping purposes.
A traverse may be of two types, that is, open traverse and closed traverse. For open traverse, a traverse is said to be open traverse when the traverse starts at one point and terminates at another point as shown in the figure.
Open traverse is also called as unclosed traverse. It is suitable for surveying of roads, coastal lines, and etc.
The next type of traverse is closed traverse. A traverse is said to be closed traverse when the traverse forms a closed circuit as shown in the figure.
In this case, both starting and terminating points of the traverse coincide with each other. It is suitable for the survey of boundaries of ponds, sports, grounds, and forests.
Instrument, which is there are 8 instruments. So the first instrument is total station. Total station is a compact instrument which weighs around 50 Newton to 55 Newton. It consists of a distance measuring instrument, an angle measuring instrument, and a simple microprocessor. So the advantage of the total station, which is we know the first and foremost advantage of using a total station is that it saves time of work on the field. It understands and supports all the local language. Setting up of the instrument on the tripod can be done easily and quickly by laser plumber. The accuracy of measurement is much higher in comparison to other conventional surveying instruments. Tripod is used to hold the total station. So, a surveyor's tripod is a device used to support any one of a number of surveying instruments, such as theodolites, total stations, levels, or tracings. The head stability under load and the minimal drift, long life, optimal vibration, dampening, water resistant, all staying behavior in solar addition and dew weight. Prism is optical survey, specially designed retro reflector, specifically a corner reflector, that is used to reflect the electronic distance measurement, which is we call EDM. Beam from a total station, a survey prism reflects the EDM beam back to its source.
Prism 1 unit. Optical
Optical survey prisms are specially designed retroreflector, specifically a corner reflector that is used to reflect the electronic distance measurement beam from a total station. A survey prism reflects the EDM beam back to itself with both the wide angle of incident The use of the pole comes directly from complex analysis and is used to denote a specific type of singularity of a given function. In particular, these singularities are precisely the point that the function belongs to the pole of the consisting of back head fixed to a long handle that is used to deliver an effect to a small area of an object. This can be, for example, to travel into wood, to shape later as with or
Now, fix a station points A, B, C, D, E, F as a closest boundary. Set up a compass at the station A. Through the compass, visit a ringing rod in the B stations, then take a 4 bearing of line A, B and note down in file book. Now, rotate a compass in clockwise directions, then take a back bearing of FA line and note it in file book. Shift the instrument to station B. After fixing the instrument, visit a station C and take a 4 bearing of line BC and note in file book. Then rotate a compass in the clockwise direction, sign the A station and take a back bearing of AB line. Shift the instrument to station C. After fixing the instrument, visit a station D and take a 4 bearing of line CD and note it in file book. Rotate a compass in the clockwise direction, sign the B station and take a back bearing of BC line. Shift the instrument to station D. Similarly, take 4 bearing of DE line and back bearing of CD line. After that, shift the instrument to station E, take a 4 bearing of EF line and back bearing of DE line. Finally, shift the instrument to F station, take 4 bearing of A line and back bearing of EF line. Measure a distance between station point A, B, B, C, C, D, D, E, E, F, and F, A.
Precaution in traverse centering. Ensure that the theodolite instrument and targets are centered correctly over each service station. The angles descent may be required from or to a non-station.
The second one is angle. When clamping the instrument, apply light clamp to the vertical and horizontal lock. A hard clamp can affect the pointing of the instrument. Keep the target in the center of the field of view. All movement of the theodolite should be kept as smooth as possible, and all movement around the instrument should be kept to a minimum.